Alright guys, this video is for Honors Algebra 2. It is going to be the first lesson in the Chapter 7, which will be 7.2, Solving Exponential Equations. As you guys know, this is the logarithmic chapter. The reason it intros with this is because logarithms are versions of exponents. So they want to lead off with this solving equations style. That way you guys have an intro material, so that'll help you with logarithms down the road. So the first slide here, we have a property to talk about, the property of equality for exponential functions. So if the b is going to be your base, okay, and b is bigger than something other than 1, okay, bigger than 0 but not equal to 1, so b's got to be 2 or bigger, basically. Then if b to the x equals b to the y, if and only if x equals y. Basically what it's saying is if you have the same base in an equation, then the exponents also have to be equal, otherwise it's not going to be, a true statement. So for example, if 3 to the x equals 3 to the 5th, since they're the same base here, x has to equal 5. There's no other way around it. So that's kind of where the premise of the lesson today is built off of. If you have the same base, like you do here and here, then your exponents will be equal. Now, obviously, I'm not going to sit there and give you a bunch of problems that say, 4 to the x equals 4 to the 4th, x equals 4, circle it and you're done. All right, so these are going to be a little more complicated, but they build off of this premise where if you have the same bases, then your exponents are equal. So to show you what these are going to look like, we have two examples here. The first one we have is 2 to the x power equals 8 to the 3rd power. Basically what you need to do is you need to make these bases be the same. So you're kind of taking your chapter 6 knowledge. And that's why I was on you guys about rethinking the way you think about numbers. It has to do with this lesson as well. You need to rewrite 8 to have a base of 2. And the way you would do that is 2 to the 3rd. So the left side stays the same, so 2 to the x equals. You rewrite 8 itself as 2 to the 3rd power. Get it a little cleaner. Okay, so that's 8. And then that's all still being cubed. So you have to cube that as well. So 2 to the 3rd to the 3rd. So rewrite 8 as a base of 2. And then I'll do your power of power rule here. So 2 to the 3rd to the 3rd becomes 2 to the 9th. Multiplying there since it's power of powers. And now that you have them down to single bases, so bases of 2's, then you can set the exponents equal to one another. So in this example, x equals 9. As usual, you should be able to go back in the original and check it out and make sure it works out. So then if we move bouncing across to the second example, we have 9 to the exponent of 2x minus 1 equals 3 to the power of 6x. So for this one here, you always want to get down to the smallest base possible, in this case that being 3. So you're looking over at 9, which is going to be 3 squared. So same concept as last time. You're going to rewrite 9 as 3 squared and take that quantity to the original power, which is 2x minus 1, which equals 3 to the 6x. A little trick on this one here, since you still have to do power over power, but when you multiply these powers, since 2x minus 1 is a binomial, make sure you distribute that 2 throughout here. So you should have 3 to the 4x minus 2 power equals 3 to the 6x power. Okay, then now that you have the same bases, you can set your exponents themselves equal to one another. So 4x minus 2 equals 6x. And then just solve it like any other equation you usually would. So I'm going to subtract 4x from both sides. So negative 2 equals 2x. Divide by 2. X equals negative 1. Sometimes they're nice problems where you just have to change the one side, like we did here. We changed 8 to 2 cubed, we changed 9 to 3 squared, and the other side stays the same. Sometimes that happens, but more often than not, that's not the case. Remember that you need to be careful here that you're looking for powers. You're not just looking for multiples. Okay, so a lot of people mess this problem up because they know 8 times 2 gives you 16, so they just rewrite 16 basically as 8 squared. And then so obviously 8 squared is 64, so that's incorrect. So you need to make sure you get them down to the same base. Now all of these in this section will work so that you can make them all be the same base. What that base is on you to figure out, which also kind of goes back to knowing, your perfect squares and perfect cubes and whatnot. Since this is one you're supposed to know, and you know 8 is 2 cubed, and so then you use that to figure out what base of 2 you can rewrite 16 as, which would be 2 to the 4th. Okay, so at least one of them every time will be something you were required to know in Chapter 6. For example, you were required to know 8 because it's 2 cubed. And then you use that to figure out what 16 is. All right, so we're talking about whenever we get to bigger numbers. There'll be a couple of examples like that later on where you use one to figure out the other. But then once you do that, same way. So distribute the 4 through. So 2 to the 8x minus 12 equals 2 cubed. Once you get the hang of it, this step here you can kind of skip as long as you know you're going to be having the same base after you distribute properly. That's my only concern. Just make sure you distribute properly, and then if you want, you can go straight to 8x minus 12 equals 3, and then solve that. So add 12, 8x equals 15, so x equals, keep that as a fraction, 15 over 8. Alright guys, you're going to work these two out and answer the questions. So I'm going to pause the video here. Your first one will be 4 to the 2n minus 1 equals 64. Your second one will be 5 to the 5x equals 125 to the x plus 2. So go ahead and work these out and put in the answers when you're finished. Okay, so hopefully you got 2 and 3 for 1 and 2 there. As you can see, these are kind of simpler problems. This is what we're going to end up doing overall. You can see here I kind of showed where I rewrite the base. You didn't have to distribute anything on this one, but over here on number 2 you can see where I skipped the distribute step here on the 3x parentheses x plus 2 and just did it outright. That's, like I said earlier, that's fine if you do that. Just make sure that you show that you do the distribute properly. So you should have 2 and 3 for 1 and 2. There are different little tricks and different things I can do with these problems. For example, one like this, where we have 2 to the x plus 2 power equals 1 over 32. Now this one you kind of want to make sure you take carefully. The first thing you want to obviously hopefully take care of is this ugly fraction. Which pulls back to Chapter 5 and how you can move terms above and below fractions. The only thing you have to change is to make the exponent either positive or negative depending on what it is and depending on where you move it to. So the trick you can do with this one is you can leave the left side alone, so 2x plus 2. And then you can make 32 be up top now, move it from the denominator to the numerator, but you have to make the exponent on it negative, which would be -1 in this case. Once you do that, then you can work with that 32 and make it be so it has a base of 2. So like I said, that's not one you're required to know, but you know 2, so you can figure that out. So you figure out that 32 written as a base of 2 is 2 to the 5th. And that's all still to the negative first. Okay, remember you're just writing 32 as 2 to the 5th, not the exponent with it. Then it goes back to your older examples where you have power of power rule, so you multiply the 5 and the -1. So 2 to the x plus 2 equals 2 to the negative 5th. And then once you have that, you can set your exponents equal to one another again. So you have x plus 2 equals -5, and then go ahead and subtract 2 to give yourself -7 on that guy. Okay, and obviously once again, if you want to go back to the top and plug it in and check it out, you can. Okay, so be ready for ones like that. You're going to have one coming up here in just a little bit. So hopefully that one went well. Make sure you take notes on that one. because this next one here is going to be, these next two here are for you guys to try the same trick. Okay, like I said, remember that you're looking at one of the numbers I'll give you, and then you're trying to figure out what this number is going to be when you move that. Be careful on 4. Okay, take 4 slow. I'm going to go ahead and pause the video here and let you guys go ahead and answer these two. Okay, so here's the answers for 3 and 4. Number 3, you should get -2, and then number 4, you should get 7. On 3, it's pretty much like the example I showed you guys. If you notice, I do start skipping a few steps here, or at least you can. If you want to go straight, if whenever you just have this, you don't need to show, 243 rewritten as 3 to the 5th to the -1st. I just go ahead and multiply those numbers together, make it -5. If you want to do that, like I said, that's your call. If you want to make that jump, that's fine. After that, set them equal to each other, add the 1, divide by 2, you should get -2 there. Number 4, it's not out of the question to where you have to flip both. Hopefully that's the way you went about it, because once you could technically, I guess, make this be 1 over 1/7 all to the 3rd power, or to the 4th power rather, and go about it that way. Sometimes it gets a little trickier, so I just move them up and make them negative here and here. Make that y minus 3 distributed through, makes it -y plus 3, and it makes it equal to -4. -y plus 3 equals -4, -y equals -7, y equals 7. You also could, if you, maybe some of you did it this way, you could also go to make it 1/7, whoops, to the y minus 3 equals 1 over 7, and then just figure out, same thing, figuring out what power 2401 would give you 7, because that's the same exponent that's going to be, what power gives you 1/7 as opposed to 1 over 2,401. In that case, it's still going to be 4. Okay, which means you would still, since you have the same basis, you would still set your exponents equal, add 3 over to get 7. Some people can see that. It really depends on your mindset as far as fractions go. If you're cool with working with fractions and just change this to the same base, it's fine. Some have trouble with doing fractions with exponents. So that's why I initially teach to move these up, make them whole numbers like we did over here every other time, and work it that way. So however you want to work it is fine, obviously. Which brings us to the last topic for this video, guys. It is money problems called compound interest. So compound interest is a formula that is used to determine how much money is going to be in an account whenever interest is added in certain intervals throughout the year. So this is definitely a formula you need to have memorized for any quizzes or tests. You won't be given it. It's A equals P times the quantity 1 plus R over N, and that quantity is to the N times T power. And if you look in the paragraph below, right here, it labels all your variables for you. It says where A is the amount in the account after T number of years. So A is kind of like your final amount. So A is final amount. T is years. P is the principal amount invested, so basically that means it's your starting amount. So your shorthanded at start money. R, hopefully, obviously, is your rate. And N is your number of compoundings. So CONP. And what compoundings means is that's the time of you get added in the interest that you've accumulated through the account. So it's going to say stuff like quarterly or yearly or monthly or weekly. So that's where you kind of need to use your common sense about this time frame throughout a year. And as we work through some of these problems, you'll learn some of these. Like quarterly would be 4 times a year. Twice a month would be 24 times a year. Monthly would be 12 times a year. 52 weeks in a year, so people forget about how many weeks are in a year, which kind of blows my mind, but still. So you'll learn all of those. The hardest one is bi-monthly, because some people can take that to be twice a month, some can take that to be every other month. So the only one I don't use is bi-monthly. There will be one in your homework that I will tell you later which one you need to use for that, so that way you don't mess it up. So anyway, so let's try one of these. For now, let me back up real quick one time. For now, these problems are going to be all just straight up plug and chug every time until we get later on in this chapter. So for now, every time we're going to be solving for A. So it's really just plugging in and then evaluating throughout your calculator. Okay, so you're going to have an investment account pays 4.2% annual interest compounded monthly. If $2,500 is invested in this account, what will be the balance after 15 years? So like I said, it's basically going through and doing plugging in numbers. So I always go through and label my parts. So 2,500 is my principal, 4.2% is my rate, compounded monthly would be my N, and since there's 12 months in a year, N is going to be 12. 15 years is my time. Okay, so the money staying in the account for 15 years, and then we find A. So we go plugging everything in. A equals 2,500 times the quantity 1 plus the fraction. Now remember, since the rate isn't a percent, you need to make it to decimal. So it goes, two decimal places to the left. So 0.042. That's all over 12. All to the 12 times 15 power. Okay. And really, for me, that's really all I need to see as far as whenever you go setting things up goes. The rest of it you're going to kind of do in your calculator from here, and then round it to your hundredths, because you're talking about money. So the only thing I still show, I kind of figure out what 12 times 15 is before I go to my calculator. So I'm going to erase that and write down what 12 times 15 is, which is 180 instead. If you want to go straight to 180 in your setup, that's fine. So if you don't have this wrote down yet, go ahead and write it down real quick. Pause it here, because I'm going to delete it and go to our calculator app. Okay, so here's the calculator simulator. Now, for plugging this into your calculator, there's kind of a specific process you want to do just to make sure you do your order ops correctly. I don't recommend plugging it all in at once, because you'll have to do multiple parentheses and then kind of make sure the notation is correct. So I would recommend doing this step by step, following your order ops as you go through. So obviously, if you look in your notes, because you have it wrote down here, I have it wrote down in front of me, the first thing you would do is look at the parentheses, and specifically inside the parentheses, the decimal and the division there. So the first thing on your calculator you should do is do 0.042. Oops, missed the 2. Thought I hit it. 0.042. Divide that by 12 and hit enter for that. And that gives you 0.0035. Okay. Like I said, okay, listen to this. Like I said, you're going to eventually round this to hundredths, but the only time you ever round whenever you're doing problems like this is at the very end. Because if you rounded this to hundredths right now, you'd be at 0. And that's not too difficult of a problem. So you will notice as we work this one, as you guys work the next one, the only place you want to round is at the very end. So it's very important here in this lesson and throughout the chapter that you kind of get used to working your calculator in the order of operations and the notating things with parentheses. So we have 0.0035, that's 0.042 divided by 12. We're going to add 1 to that, so we're going to go plus 1 next, hit enter to give us that. And this is where it's going to get ugly. So we need to take that quantity, since it's inside parentheses. Exponents go first, so then we're going to take it to the 180th power. So answer to the 180, hit enter there, which gives us that long decimal number. Like I said, you don't want to round that off there. Your answer will be off from mine, not by much, but still slightly. And then the last thing is take that times the initial amount, which is 2,500. Hit enter one more time. That should give us $4,688.866166. We want to round it to hundredths, So you don't worry about that. You look at the third number. Since it's 6, bigger than 5, so you go up with the next one. So your final answer should be $4,688.87 when you round. Okay, so it's very, very important to make sure that you guys are properly using your calculator functions to go through with that. Okay, so hopefully I have that answer wrote down here. I'm going to go through everything one more time quickly, just because you guys will do the next one by yourself. So just to go through one more time, make sure everybody's got it. First thing you do is do 0.042 divided by the 12 to give you that fraction first. You add the 1 inside the parentheses to that. You then do your exponent rule to take that to the 180th power to give you that. And then you times that by the 2500 that you started with, and then round. So hopefully you have the kind of that process. It's basically doing each order of operation within your calculator itself. Okay, so let's see. Let's go ahead and pull this up. And then this one's going to be for you guys. So go ahead and try to figure this one out. Find the account balance after 20 years. If $100 is placed in an account that pays 1.2% interest compounded twice a month. Alright guys, hopefully you got $127.12. Hopefully your rounding did well on this one here. Like I said, just make sure you understand where everything goes. And like I said at the beginning of this section for the problems here, you're always going to solve for A for now. So first section here, later on we'll be able to do other stuff inside, solve for different things with what we're going to learn. But for now all you can do is just plug in these numbers and then turn it out of your calculator. Okay, so your homework assignment for this is going to be page 464, 9 through 14, 20 through 23, and then 24 through 29. A couple of last minute things about this. First off, 24 through 29, they're like the first type of problem we did. They're inequality signs in the book. All you need to do to fix that, just change them to equal signs and work out the problem just the way you would. Okay, so your answers in the back, you should get the same numbers every time. I'm 99% sure of that, that you get those. The other one that we need to talk about is number 22. I thought I had it wrote down in my book, and I'm not going to pause the video just to work it out myself. I'm pretty sure 22 is supposed to be a compounding of 6. It's one of those that I said earlier, it's the bi-monthly one. I'm 99% sure that you're supposed to do an n of 6 in the book with compounding by bi-monthly. So every other month. I might be wrong on that, so don't quote me on that. But you should get n equals 6 on that one. We'll work it out in class to make sure it is. So once again, on this last set here, change these inequalities to equal signs, and then for number 22, use n equals 6.